Okay, so it's stated in problem 103 on page 605 that the capsize screening value C should be less than 2 if a boat is to be considered safe for ocean sailing. The formula is given as C equals to 4D to the negative 1/3 B, where D is the displacement in pounds and B is the beam width in feet. The exponent of minus 1/3 means that the cube root of D will be taken and then the reciprocal of that number will be used in the multiplication. I have a friend with a 1963 Cascade 29 sailboat for which I am going to find the capsize screening value. His boat has a beam of 8 feet 2 inches and a displacement of 8,500 pounds. Okay, so the first thing that we need to do is we need to, so we have the formula, right? C is equal to 4D to the negative 1/3 times B. Okay, so D is the displacement in pounds, B is the beam width in feet. So we're going to plug in those numbers. So I have D, the displacement, is 8,500 pounds, because that's what it says right there. And the beam B, it's 8 feet and 2 inches. So 8 feet and 2 inches, I need to turn that into decimal form. And you remember that there are 12 inches in a foot. And so these 2 inches are going to be 2 over 12 feet. And so if I write that as a decimal, that's going to be 8.17 total. So 8.17 feet is going to be the beam that I'm going to plug in. Okay, so if I put all of that in, I would get that C is equal to 4 times 8,500 raised to the negative 1/3 times 8.17. Okay, and so then this is equal to 4. Now 8,500 raised to the negative 1/3. If you plug that into a calculator, you should get 0.049 if I round it to 3 decimal places, and then times 8.17, and that is equal to, if I multiply those three numbers together, 1.60. And notice that's less than 2, so that's good, because the capsize screening value, it says, should be less than 2 if a boat is to be considered safe for ocean sailing. So this boat is safe. Safe. Okay, good job. Okay, now for the next part, you have to solve for a variable in a formula. Now, in your problem, you're given a formula and you're asked to solve for D. I'm going to do a similar example with different variables. So my formula is D equals to 1.1 G to the negative 1/4 times capital H. And I'm going to do this example, which is similar to yours, but I'm going to solve for G. So I'm trying to solve for this variable G here. Okay, so the first thing I'm going to do, since I'm trying to get G all by itself here, that means that I need to move this 1.1 and this H. Now, what operation are 1.1 and H doing to G? Well, they're multiplying G. So to move them to the other side, I'm going to do the opposite operation. I'm going to divide by 1.1 H on both sides. Okay. Now, if I do that, I'm going to get D over 1.1 H is equal to g to the negative 1/4, because notice 1.1 and 1.1, those divide into 1, and then h divides the h, and so I'm just left with g to the negative 1/4. Okay, now the next thing I need to do is I need to get rid of the negative 1/4 power. So to do that, I'm going to use the power rule. So I'm going to raise both sides to the negative 4th power. Now here the power rule says that you multiply the exponent. So negative 1/4 times negative 4 is simply equal to the number 1. So on the right side, I end up with just the variable g raised to the 1, and I'm not going to put that exponent, so it's just g. And then on the left, I end up with d to the negative 4th over 1.1 h, and all of that to the negative 4th. Now, just like we did in the previous problem, so the negative exponent turns it into the reciprocal. So that means that d is going to be to the positive 4th in the denominator. So it's like you move it down. And then the 1.1h is going to be moved to the numerator. 1.1h, and then to the positive 4th. That's equal to g. Okay, now here I have 1.1h to the 4th. Well, let's simplify this one more step. So 1.1 raised to the 4th, that's equal to 1.4641, and then h to the 4th. So notice all I did there was raise both the 1.1, raise that to the 4th, and raise the h to the 4th as well. And then that divided by d to the 4th, and that is equal to g. So now I have solved for g on that problem.